G'day team, welcome back to another video, and today we're going to introduce function notation. Now function notation is something that you'll use a lot as you keep going through with maths at uni, even in end of year 11 and year 12, it is something that is really important to get used to. So we sort of look at a function like a bit of a machine. So we have an x value input. We put it into our function and we end up with our output, which is a y value. Okay, so we're still using our x and y's. We're just going to represent it in a different way. So typically we'll use f to denote a function, but functions can be called and named with all bunch of different letters, and we'll practice using different letters later in this video as well. So if we look at a bit of an example of a function, so we've got f is the function that will turn x into 3x plus 7. So f would convert x equals 3 into, so that x becomes a 3. I've got 3 times 3 is 9, plus 7 is 16. So instead of having x equals 3, my function turns it into 16. If I put negative 2 in, 3 times negative 2 is negative 6, plus 7 is 1. So my function turns x equals negative 2 into positive 1. Now there's a couple ways we can denote functions. We're going to look at one that typically doesn't get used but is a really good definition. And then we'll look at one that we are actually going to use and probably will carry forward as we go through videos. So we've got the function f such that x is converted into 3x plus 7. Now that is one way to represent a function. Now the more typical way is something like this on the right hand side. The function f of x equals 3x plus 7. Okay, so this will be the one we typically use, and if you see something like this, we can sort of see that f bracket x equals 3x plus 7. So you can see that they are similar, and we typically use this one on the right, okay? So we are going to define y, so our y coordinate is equal to f of x. So one thing that you really need to get into your brain is if I've got an f of x number or an f of x value, that is the same as a y value, a y coordinate. So we can also represent, if I have a function y equals 3x plus 7, it is defined to be the same as being f of x equals 3x plus 7. So they represent the same thing. So y equals 3x plus 7 is a straight line. F of x equals 3x plus 7 is also a straight line. So really important thing to remember. So if we come down, here we can see we've got 3 different functions. And like I said, we're going to practice using different letters. So I have f of x equals 3x plus 2, g of x equals negative 2x take 1, and h of x equals 2x squared. So what we're going to do is we are going to choose specific x values and substitute them into our functions. So so we've got f of x equals 3 times 3 plus 2. So we can see that my x in my function has become the 3 that's inside the bracket. Now 3 times 3 is 9 plus 2 is 11. Now g of negative 2. So now I'm looking at my g function. So I'm going to write g of negative 2, and wherever there's an x inside my function, I'm going to replace with negative 2. So negative 2 times negative 2, take away 1. I've got positive 4, take 1 is 3. And then finally with h, we've got 2x squared. So h of negative 3 equals 2 bracket negative 3 squared. Now negative 3 squared is 9, and 2 times 9 is 18. Now, what also can be represented here is a coordinate. So an x and a y coordinate. Now the x values are super easy to pull out. They are the values inside the brackets of the function. So I've got 3, I've got negative 2, and I've got negative 3. just realized this here should be 3. Now the y coordinate is the result of the function having the x inputted into it. So the first one is 11, then 3, then 18. So I've actually got a set of coordinates, okay? So with that, we can apply function notation to a graph. So I've got my function, f of x here, and it looks a bit like a cubic, but ignoring that, we're just looking at f of x. Now, I want to find f of 4, but I don't have an equation to substitute it into. But remember, f of 4 is the y coordinate at the specific x value 4. So if I've got 4, x is 4, go up to my function, that y value is 3. So f of 4 equals 3. F of 6, I'm going to go across to 6 to my function and across, that is 1. So we're looking at the coordinate 4, 3 and the coordinate 6, 1. I hope that clears up function notation a little bit and you can now hopefully have a crack at some questions. And if you're using the Hazy textbook, these are the questions I would love for you to have a crack at.